Now we move on to another comment from Jens Nimes on the actually why clouds were invented. Originally, it was to solve the underutilized server problem because that wasted computer power to have lots of servers each running at 10 to 20% utilization. It was partly due to a trivial reason. When you mixed applications, they started interfering with each other, and their um, virtualization helped you because it isolated those different applications. And the other issue was overutilized servers, which caused interruption, for which you need elasticity to add new servers on demand. Of course, as we're moving to the cloud-dominated application area of social media and search and e-commerce, we have highly dynamic resource demands. You need lots more servers for YouTube when you put on some sort of exciting video, which is real time, such as I don't know the ice hockey between Russia and the USA. And all of this is internet scale because users are across the world, across the globe. And we need on-demand resources because that gives you faster time to market. You can do your stock trades in essentially real time, and innovation time is cut down because there are no unnecessary communication delays. Meanwhile, we're developing the web as a cloud to basically build the web as the infrastructure on which we build. I remember thinking about this almost 20 years ago, that was a nice thing to think about doing. Actually, it's more like 15 years ago, around 97. And at that time, the web wasn't so smooth, but now it's rather clear that you can build lots and lots of things. Whole applications can be built solely on the web, and that's giving you technology, business, and people all working together. And this uses services, sometimes so-called web services, sometimes so-called REST services, and then we are building this ecosystem of services which are joined together to build large-scale applications. Another interesting idea behind the cloud is as an extension of your desktop and other client devices. And we know we can use cloud storage. My laptop is backed up to the cloud. I do a lot of my collaboration on the cloud with Google Docs or Office Live or SkyDrive and things. It keeps changing its name. But they're all basically files shared smoothly between participants around the country. We have various collaboration spaces. I would use Sakai and SharePoint as not clearly the most exciting. Most people would probably use quote social media sites like Ning, Facebook, and Twitter, and Google Docs, Dropbox, those types of technologies are today's winning collaboration ideas. Another important aspect of this down here is the lens that magnifies the power of the desktop. There's nice examples we'll see later on where Excel runs on your desktop and has an unreasonable number of rows and columns, and you basically don't actually store those on the desktop. There's just an illusion. All the computation is done in the cloud. The data doesn't, those billion rows do not exist on your desktop. They exist on the cloud. However, when you execute a computation, like summing up a particular column over those rows, that computation is done in the cloud and downloaded. So all you see on your desktop is the aggregation of all those rows. And that there was Excel, but the same idea can be done with R, with MATLAB, and lots of other computation models. Here we're focusing on the actual game of the slide from Microsoft on the properties of clouds. They're designed to provide information and computation to many users. We obviously, again, have the automatic deployment and management of virtual machine instances. This has to scale. We have up to maybe 1 million servers in one place, so that's quite a lot of scaling. And also you can scale across data centers. But an individual application is going to be using a smaller number of such nodes or such cores or such virtual machines. We have a lot of focus on fault tolerance for clouds because clouds actually trade off scalability versus fault tolerance. They actually have more faults than traditional clusters. but they scale much better than traditional clusters. But the fact that that happens means that the cloud applications that are successful put particular attention into fault tolerance. We have data replication, which can be done automatically for this when you store something in Amazon. S3 is actually stored on multiple disks, and that's typically done in different data centers, because obviously you don't want to store everything in one data center, because that would be unfortunate if that data center went down. And then all the jobs on the clouds have these two types of parallelism. The parallelism within a task, when you do a search, maybe that search runs over several cores. And then we have parallelism among users. We know we have endless number of users actually doing searches continuously. Here we have another aspect of what the cloud is. It is basically an amalgamation of various data center models. We have public data centers, private data centers, and we have hybrid data centers, which maybe have sensitive things on the private part, and large computations which aren't so sensitive on the public data center, so they develop maximum cost effectiveness. And everything, as we see here, is done as a service to give us the illusion of infinite compute and infinite storage.